When we think about a building's impact on the environment, our minds usually go to things like electricity use or heating bills. But what about the huge carbon footprint that's created before anyone even turns on a light switch? Well, today we're diving into a whole new blueprint for designing greener buildings right from the ground up, using a pretty smart mix of AI and human expertise.
All right, so let's get into it. Every single building around us, from the tallest skyscraper to your local coffee shop, has this kind of hidden environmental story. It's this massive carbon footprint that starts long before the doors ever open. They call it embodied carbon.
And get this, it turns out that up to 81% of a building's entire lifetime carbon emissions can be locked into its materials and the construction process itself. That's just wild. It means the huge majority of a building's environmental damage is already done before day one.
Now, to measure all of this, regulators require something called a life cycle assessment, or an LCA for short. Think of it as the building's complete environmental biography. It's the official way to calculate everything, from where the raw materials came from to the manufacturing, all the way to what happens when the building is torn down decades from now.
But here's the catch. Actually doing one of these LCAs is incredibly slow and complicated. It's like trying to solve a giant 1,000-piece puzzle with a blindfold on. The process is so difficult that architects often have to make massive decisions, like which materials to use, without having this critical environmental data in hand.
And this creates a huge problem for sustainable design. You've got this process that's absolutely vital for building green, but it's just way too slow for the fast pace of modern architecture. It's like trying to build a cutting-edge race car using nothing but hand tools.
So designers are kind of stuck between a rock and a hard place. You've got the traditional, manual way of doing an LCA, which is super thorough and totally compliant, but it can take weeks. Then you have standard AI models that can spit out an answer in seconds, but they're basically black boxes. You can't see how they got the answer, which is a big no-no for regulators.
This quote from the research just nails the problem perfectly. The old tools are all about just crunching the numbers, and a lot of the newer AI tools go for speed but throw transparency out the window. There's this huge gap between the reliable answers we need and the speed we want.
So what's the answer? Well, it's a best of both worlds framework, one that combines the incredible speed of AI with the strict, non-negotiable rules of the official standards. What you get is a tool that's not just smart, but also totally trustworthy. Okay, so let's break down how it actually works. The whole system has 4 layers. At its heart is a solid, rule-based core that follows the official guidelines perfectly. Then there's an AI layer that does all the heavy lifting. And this next part is key. There's always a human expert in the loop to check the AI's work. And finally, everything it produces is completely audit-ready.
Now, the AI's secret sauce is a machine learning model called an XGBoost surrogate. I know, that's a mouthful. But just think of it like this. It's a super smart assistant that's been trained to predict the carbon impact of different design choices, like swapping steel for timber almost instantly. It means you don't have to do that whole slow, manual calculation over and over again.
And I really want to be clear about this. This is not about replacing the experts. It's about giving architects and engineers a powerful new co-pilot. It's about creating this seamless team where human and machine intelligence work together.
And here's how that partnership works in practice. The AI goes and automates all the tedious, boring stuff, right? Like making lists of materials or imagining different future scenarios. But, and this is the important part, a human expert always reviews, tweaks, and signs off on every single step. Nothing gets approved without a person having the final say.
So the bottom line is this. The whole point of the tool is to make human experts even better. It takes their incredible knowledge and intuition and just makes it faster and more powerful. It turns what used to be hours of painful data entry into just a few moments of making an informed decision. Okay, so a human-machine team-up sounds fantastic in theory, right? But how does it actually perform in the real world? Well, the framework was put to the test on a real case study, a 6-story timber building. And this is where things get really cool.
First thing, accuracy. The AI model scored an R-squared of 0.96. Now, for those of us who aren't statisticians, let me translate, that's insanely high. It basically means the AI's super-fast predictions were nearly identical to the results from the old, slow, manual method. The AI basically got an A+ on its test.
And the average margin of error? Just 5.5%. That's a super tiny difference, which proves that the model is more than reliable enough to be used for making those big decisions early in the design process. So you've got the speed and you've got the trust.
Now, here's where this framework really becomes a game changer. It can instantly show designers the project's carbon hotspots. In this case, for this timber building, the analysis showed that the biggest problem areas were steel parts, then the insulation, and then the timber itself. This lets designers focus their energy where it'll make the biggest difference. Talk about getting the most environmental bang for your buck.
And this table here, it gives us the whole story over the building's 50-year life. You can see the carbon cost upfront from making everything, you can see how the wood actually stores carbon while the building is in use, and you can see the impact at the very end of its life. It's the complete journey, from cradle to grave.
So what was the final result of all this? By using the framework to get rapid feedback, the design team could test out different options and ended up with a real, measurable 5% reduction in the building's total carbon footprint. Now, 5% might not sound like a huge number, but on a massive building project, that's a major win for the planet.
So what's the big takeaway from all this? Well, what we're looking at is a huge shift. We're moving away from slow, backwards-looking reports and towards dynamic, real-time decision-making. It's like going from looking at a single old photograph of a building's environmental impact to watching a live video feed of it. And this matters because for the first time, it makes true sustainable design practical. The whole process is faster, the answers you get are more accurate, it's completely transparent, so regulators are happy. And most importantly, it gives architects the information they need right when they need it most, at the very beginning of the creative process.
And that kind of leaves us with this final thought. A tool like this isn't just about faster math. It's about imagining a future where a building's environmental impact isn't just some report you look at the end, but it's an integral, living part of the design itself, right from the very first sketch. What could we build if getting sustainability feedback was truly instantaneous? It makes you wonder what other huge problems we could solve with this kind of smart, human-in-the-loop AI.